In this video, we will continue with PLC programming and we will create two different types of POU, which are function block and function. So a function block is a functionality, so we will create a pump management function block, and a function is a calculation. For instance, the percentage is a function which does not exist in T-Box, so we will create a function to have the percentage of an analog input. So let's start with the function, so I call it %. I select the language, the same as for program. You can create function and function block in ladder logic or basic. I will select basic, and you select the type. And when you select a function, you have to select a format of tag which correspond to the output of the function. And we click OK, and we have a new POU of type function. Let's double click on our function to enter into the editor, and the editor is exactly the same. There is something new, which is the list of tags on the top of the script. This list of tags contains the arguments of the function. Arguments correspond to inputs and output. And as I said that in a function we can have only one output that has been created already, so we can add inputs. A maximum of 15 inputs because the total number of arguments is 16. So let's add our input arguments. So the first one is the input I will want to scale. It's an input and it's a format float. Let's take everything in float. Then I have to add other argument corresponding to the scale of my analog input signal. So I have a min argument, also float, and I have a max argument, also an input type float. Okay, now we can do the code. So the first thing we need is to know the scale of our input. So the scale is the max minus the min. Okay, I have here a new tag, scale, which does not exist anywhere. So this tag has to be declared. It is not an argument, it's just used to make the internal calculation. So I can add a POU tag, I call it scale, and you see it's a local tag, also type float. And you can see from the icon, it's just used internally. Here we have an icon for output, for input, for internal calculation. I need another calculation, which is to bring my input to an absolute value. So let's make a new tag called temp, which is my input minus min. Okay, so in case my minimum value of my scale is not 0. You see, as before, when I explained the basic, you can put space, no space, capital letters, small letter, it doesn't make any difference. Here again, this tag temp does not exist, so I can create it. Temp, it's a local tag, type float. Okay. By the way, there is another way to create local tag, which is with the keyword dim, like dimension. So you can create tag like this. Okay, so having the tag here or having the tag here is exactly the same. The advantage of having the tag in the list of tags is that you can see its value. When you create it like this, you have no access to the value. So I will not use this one, I will just put this as a comment. Now I can make the calculation, and what is the calculation? It is % equal temp multiplied it by 100 divided by the scale. So this is my function. Let's call it now from a program. So we will call it from, for instance, pump. We will call it from a ladder program first. So I will scale my water level. So remember, my water level tag is a tag that I had scaled min to maximum 10. So let's scale this to a percentage. So I go to my program pump. I double click under the last line. I enter into ladder edition. I select the object function block. I click the folder this file and I select the POU %, and I will now assign tags corresponding to the output arguments and input arguments. So I have to select a new tag which corresponds to the scale, so I will just call it scaled. I press enter and the tag does not exist. So TwinSoft prompts me to create the tag, and as you see, it can be a local tag, which means a tag that will be present into this list here, only usable into this program here, or it's a global tag, so it's a tag which comes from the list of tags and can be used everywhere in the program. So let's take it as a global tag. The format is float, okay. Then my input is water level, so it is in the IO water level. The min is 2. You can type also constant, and the max is 10. So my line is done, so I can compile and escape to return to visualization, and now I can send this to Tbox and see the result. Sending is complete. Now to see the result, I would like to see both tags into the same list. So for this I could, for instance, use the watch window. Remember the watch window? I have already my water level into it, so I can maybe remove some tags that I don't need at the moment. I will add a watch and I will select scaled, and I see my scale tag and my water level. So if I turn my water level, which corresponds to an input in my Tbox, you see that when I am at 10 I have 100%, and when I go below to 2 I am at 0%. So here is the function called in ladder. Now if you want to see the internal code inside the function, this is possible, but you have to make sure you start from main. So I go to main and I have to access the code of the % from the main. So I double click inside pump and I enter into the pump code. Then I double click into % block and I enter into the source code, dynamize with the tags I have assigned to the function. So you see this is my input. So if I turn the potentiometer, I see this tag changing. I see my scale, which is 8, it's 10 minus 2. I see my temporary value, which corresponds to my input minus 2, and finally the result. Be careful that with a function, the same internal code is used each time you call the function. So in order to test the code, you have to call the function only once. And then you access the code as I have done from main, and then you can test your code. If you call the function several times, the local tags will be dynamized according to the last call of the function. Now let's see how we call a function from a basic program. So let's go to our program water. Remember, when you press F8, it opens the list of available function, and if I type %, I will see the function % is available with the indication of its arguments and the format of the function, which returns a single information. So I will just select my scale tag equal %. It appears in blue, indicating it's recognized as a function. Open the bracket, then I have the tags or constant corresponding to the argument. So the tag is the input, it was my water level, and the min was a constant 2, and the max was a constant 10. So that's it. So this will do exactly the same as what we did in the ladder. So that's it for the function. Now let's take a look to function block. In my list of programs, I click Add a POU, and I will define a function block for a pump management filling my water tower. So I will call it one pump. The language will be also basic, and I select function block. When I define a function block, I have no special format to define, like when we do with a function, because in the case of function block, I can have many outputs and many inputs. Maximum 16 total arguments. Click OK. I double click the POU and I enter into its addition. I will first create the argument. So in my pump, I want to have an automatic and manual mode. So I will first create a mode tag, which will be an input for selecting manual or automatic. When I am in manual mode, I have to be able to start and stop my pump. So I will create another input for starting in manual mode. I also have an emergency stop. So I will create a new input emergency, also a digital one. Then my pump will fill my water tower. So I have to control the level of the water in my water tower. So I have to create a new input, which is the level, which is in this case a float input. And I have to define a min and a max level. So level low input float and level high also an input float. Then I have my pump output. So pump output. The tag already exists as a global tag. So are you sure you want to name this tag pump? Yes. There is no issue doubling the name. And finally, I would like to calculate the time my pump is running. So for this I will use a counter. We will see that afterwards, but I can already create my tag returning the number of minutes my pump runs. So I click time in minute. So it will be an output and it will be a D word. Okay, all my arguments are done. I can put some commands and start doing the script. I have put some comments to the tags used as arguments and I have started the script. So let's take a look to it. First I will close this watch window to have a better view. So we can go to view, watch, and you see the accelerator key is Alt 3. So I have here, I can see now all my script. First, I will determine when there is a request to fill the water tower or not. So in which case do we have to fill? In any case, when the level in the water tower is below the lower level, or if I switch back from manual to automatical mode and my level is below the maximum level, then I can fill. In which case are we going to stop filling? In any case, when the current level of the water tower is above or equal the maximum level. Now you see this fill tag does not exist. It's a local tag just used inside the function block for the computation of the filling or not filling. So I will just add a POU tag, fill. It's a local tag of type Boolean. And you can see from its icon, it's not used as argument. Now, regarding the pump activation, when will the pump be activated? when there is a request to fill and I am in automatical mode. Or if I am in manual mode and I have a request of starting the pump with my manual activation, and of course if the level is below the maximum level. And in all cases when my emergency is not activated. So if one of these conditions is true, the pump will be activated. Otherwise, the pump will be stopped. I still need to compute the time of my pump activity. So for this I will use a counter function. So I am in the manual basic and ladder. So the counter function has, like for the timer, a preset, a value and a state. And the ring counter will increment itself each time it receives the pulse, and this pulse will be second, and the preset will be 59, and the ring counter restart counting when it reached the preset. So when it has reached 59 seconds, the next pulse will reset the counter and it will restart from 0. So this ring counter will compute for me minutes. Let's go back to the program. So I need to create an instance of the counter into my list of tags. So when I click add a POU tag, I can also select a counter instance. So I would just call it counter. It's a local tag, okay, because it's a local instance inside my function block. And then I can associate a digital tag as a counter status. So I click counter status, and it's a counter status from which counter instance you select. The counter instance is the instance counter. So I have created my variables, so now I can make the code. So the code is counter. If I don't know the name, I press F8 and it will show me the possible counter, and it's count ring. Then what are the arguments? The name of the counter, the activation of the counter, and the preset. So the name is counter. The activation of my counter will be if pump equal 1, and if I have a positive edge of tick second, remember tick second, or a negative edge of the same tick second. So it means it will cover each second, and my preset will be 59. I have to make sure I have done the right number of brackets. Okay. So my counter is called, and then each time I reach 59 seconds, the status of the counter will change to 1. So if trigger pause counter status, then inc time min. That's it for the time computation. I missed one bracket here, so let's correct this here. Okay. It's not finished yet, because we have to take into consideration the fact that the local variables here of a function block, when T-box starts, they are initialized to 0. So it means this time minute will be initialized to 0. But I want this to maintain the time my pump has been running. Even if my program restarts, if I send a new program, I want to hold the current minute of activity if it corresponds to weeks or months. So for this, I will first have to initialize this variable. This is the output argument with my pump activity time that will be assigned to a global tags. Now I have to initialize this variable when the program starts, taking back the value of these global tags into an input. So I have to add a new argument, which is the time input, which is an input, which is a D word, so equivalent to the output, and I will call it time input, and this one here, pumping running time, this is output. Just adapt the command. And in the script, before my program starts, I will add a new line. If trigger pause PRG run. So this is a system variable. If I go to the resources, system variable PRG run, which changes from 0 to 1 when the program starts. So I can use this information to initialize a value at program startup. Now this variable is not tagged, so to use a system variable which is not tagged, you just put its name and then exclamation mark. It means it will use the system variable even if it is not tagged. So at the program startup, what will I do? I will initialize time min equal time input. So I will take the current minute inside my global tags and I will assign it to my tag computing the time into my code. So that's it. Now we have done everything. I will maybe just rearrange a little bit this one so that I will put all the inputs together so that when they are listed together, the input and then the output. Okay, that's it for the function block. Let's see now how we will use it into our process. But before that, we will define the resources. Imagine that in our process we have 3 pumps we want to activate using this function block. So we will first create the tag. So it means if we have 3 pumps, okay, we will need to have 3 pumps output. So I will create a pump 1, and we will work with internal variable for this exercise. So I can just copy paste to have 3 pumps. Then I also need 3 levels of tanks. Okay, level 1, which is a float. Okay, I copy paste, Control C, Control V. I need also 3 manual start. I will call start 1, which is a digital tag. Okay, copy paste. I also need 3 mode selection, manual automatic. I call mode 1. I can also copy paste. And finally, I need 3 tag with the time of pump activity, which is an analog tag, time 1, which is a D word with the minutes. So I copy paste, and I have my resources. Let's call this function block from ladder logic. So I go into my ladder program. I will close this result window here to maximize the view. I double click under the last line. I select my function block program object. In this file I select my function block, and I have to give an instance name. The instance name allows Tbox to make distinction between the different call for the different pumps, because each pump has its own activity. Then I assign tags to my arguments. Either I know the name of the tags and I can type it, or I select the tag from the list. if I know the name of the tag, it's start1, so this one is to start the pump manually. Emergency, I have not defined any individual emergency tag, so I will take the global one. Then level is level 1. Let's say my tank varies from 2 meters to 10 meters. Then my time input, this allows to initialize the time in minute in my function block, and then the pump, and finally the time output, and my instance is now created. I can accept changes, and I have done one call for a function block. If I have 2 pumps, I can just copy paste this. It will create a second instance. As you can see, it has created a second instance. It has incremented the name, and I can edit the line to change the tags. So this is pump 2. I have finished editing my second call to my pump function block. So let's say that in this case I have a level between 0 and 100%, and all my tags are associated now to the pump number 2. Let's send this to T-Box and see the result. My T-Box has now restarted. So if I want to see the code dynamize with my specific function block, for instance pump 1 or pump 2, I have to access the source code from the main. Remember what we did with the function, it's the same. So first I will display my tags, and I will display tags and code at the same time so that I can see my resources as well as the code. So I have to start the program from main. So my function block is called in pump, so I click inside the block pump. Inside the block pump I access, let's say, my pump 1, so I double click inside the call of pump 1, and then I see the tag dynamize according to pump 1. So the tag, all the tag associated to pump 1 will be visible in this window here. So if I change the mode here, the mode 1 is 1, the value here is 1. The level low and high for pump 1 was 2 and 10 meters, and the current level is this one here. So if I increment it by pressing plus or decrement by pressing minus, I see the code is dynamized, and I see that my pump is active because the current level is below the high level. Now if I want to see the same for my pump number 2, so I go back to main, I double click pump, I double click inside the pump 2 instance, and then I see the code dynamize with my pump 2 tags. So the low and high level is now 0 to 100%. The mode is 0, okay, because the mode 2 is 0. So if I change here mode 2 to 1, I will see its activity. So on this way you can debug each instance of the function block. Let's see now how we call a function block from BASIC. So I will just close this window here. So I go into my BASIC program. We have to create the instance to the function block. So in my list of local tags, I click add a POU tag. I type, for instance, pump 3, and I associate it to an FB instance, and I select my function block. Now I can use this instance in the code and associate the global tags to it. So it's pump 3, and then between brackets I have to associate global tags to each of the argument of my function block. So I have no visibility like this. So if I want to see which are the arguments, I can type the function block as it is, so 1 pump, and then if I open the bracket I can see what are the arguments of the function block. So the mode, the start, the emergency, the level, and so on. So I have to put tags here in my call here. So the first one was the mode, so it's mode 3, comma, start 3. Then we have the emergency. Then we have, I think, the level 3. Then we have the minimum, let's say 3 meters to 8 meters. Then we have the time 3. Then we have the pump 3. And finally the time 3. And that's it. To debug an instance of a function block called from BASIC, so the same as for ladders, so we start from the main. So our instance is in the program water, so I double click inside water. Then I have to press Control and double click on the instance name, pump3 in my case, and then I enter into the source code Dynamize with the tags associated to the instance. So mode 3 in my case, so if I activate mode 3, I will see that my tag here, mode 3, changes to 1. If I change the level 3, I will see the level here of my pump 3, of my water tower 3 is increasing. Okay, that's it for function and function block. One of the big advantages of function and function block is that it can be saved in a file called a library, and this file can be used in any application. So the function and function block that we have created here can be used in any other application. But before I show you that, I had to modify a little bit my code here because of this tag tick_second, which was related to the tag here tick_second, which is a global tag, and a global tag cannot be used in a function block, otherwise it cannot be exported into a library. So I just added the exclamation mark next to it, so now it's make reference to the system variable directly and not to the tag. Okay, let's look to the library. So we go to Tools, Library Manager, and then we will import POU. So we take the POU from the current application one by one, and then we can save this as and we will call it my library, and I save it. Now I will make a new application, so I make new, save yes, so I make a new MS32, whatever, it doesn't matter. I will save this application in the same directory as where I have put my library. Okay, I call it new, for instance. And when I go to File, Libraries, I see I can select one library, which is my library. I can edit, close, and when I go into my programs, put a program function block, I see I have a new file, my library, and I can select the function and the function block. So I give an instance name, the same as before. And by the way, if I don't have the tags yet to assign to the argument, I can just press escape, 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 and save it like that. And later on, when I know the tags, I can just edit the line, double click next to the block, and then you can assign the tags. We provide one standard library, including PID function. So this is installed with Twinsoft. If I edit, then I can insert PID functions, PID, and you see there are several PID functions, and I can assign tags to this PID function. Those PID functions are documented from the Twinsoft directory. You will find a PDF document with all the documentation, and there is also an application containing all the source code of the function block. So this is it for function block and libraries. Let's now take a look to the questionnaire. The question for this video, so as usual, continue with the same application. You will create a function in language BASIC that you name %, and which is of type float. When you open the function, you will see that there is already an output argument named %. You will add the input arguments input, min and max, all in float format, and two local tags, scale and temp. You write the script as in the video. You call the function from your pump program, which is a ladder program, with a new tag scaled as output. You send the program and do the debug as you have seen in the video, and take a snapshot of the list of local tags of the function. Then you create the function block, also in BASIC you name onepump. You create the argument as in the video. Be careful to select the right type, local input outputs, and bool or float or whatever. You write the script as in the video. Be careful when using system variables to add the exclamation mark at the end, so to make sure that we use the system variable directly and not global tags in case they have been defined as tags. Call the FB from your program pump with the appropriate tags or constant that you will have created. Send the program, do the debug of one instance of the function block, and take a snapshot of the list of local tags of the function block. Send us the two snapshots and the application. Good luck!